Alright, welcome back everyone. So let's get down to using the Rayleigh's method, continue off from where we stopped in part 1 of this video, part 1 of this series basically. Alright, so just to recap, quick recap, we found the K stiffness matrix, and right now all we have to do is go back and just use the Rayleigh's formula. So let's copy and paste this. And take that and copy, and I'll show you really quick how to use this formula. It's really easy and simple. All you need to know is basic matrix operations, and once you know how to do that, this will be like a breeze, pretty much. Okay, let's use a different color here. Use that color. Alright, so omega squared is equal to, so x here, we've talked about this before in part 1. Assume the mode shape to be 1, 2, 3, and now it's just transpose. So basic matrix operations, transpose is basically just bringing the turning the column to a row. That's what we did right now. And now the K, we're gonna have the K matrix right here, and then times the mode shape again, 1, 2, 3, and that's going to be divided by 1, 2, 3 again, and in this case here, since this is a torsional system, so we're going to replace M by J, O, or J. I'm going to say J matrix, and then 1, 2, 3 here. Alright, so in this particular example, what they have said here is that KT1 is equal to K2, TT2 equals to KT3, and that's going to be equal to K. And then for J, they said J1 is equal to 2J O. Let's do that again. Basically, J1 is equal to JO, which is equal to 2G, which is equal to and J2 is equal to 2JO, and J3 is equal to 3JO. Alright, so if we do that, I'm going to go back to this matrix here, and let's reduce this matrix here. So essentially here what we have is, so this is going to be 2K, that's going to be negative K, then 0, that's going to be a negative K, that's going to be 2K, that's going to be a negative K, 0, negative K. I hope you're following along with what I'm doing right here. So I'm going to take that matrix and bring it on. Copy, let's go. Alright, so we've got the matrix here. So now what we're going to do is bring the K out and reduce the matrix again. Alrighty, so bring the K out, so that's going to be 2, negative 1, 0, negative 1, 2, negative 1. And then that's going to be a 0, negative 1, 1. Alright, and then for the J matrix, we're going to have JO outside here, and then we have 1, 0, 0, 0, 2, 0, 0, 0, 3, and that's our J matrix. So going back to where we started off this video, so let's basically take this here and build upon that. I hope you guys are following along. This is really easy. It's very simple. It's just, I just like to structure the steps and procedures just that it's just clear enough for you guys. Okay, so so based on this here, we're going to sub in the K and sub in the J, and this is what we're going to get. Let's go to a new page. Squared do that. We're going to need a lot of space here. So 1, 2, 3. Okay, and then we're going to keep the k out here. And then 2, -1, -1, 2, -1, 0, -1, 1, and then 1, 2, 3, and then that's going to be 1. It's funny as I'm doing these videos, sometimes I reach when I want to erase something, I actually reach out for my eraser, which is really hilarious. I find that it's just you got okay. So 0, 2, 0, 0, 0, 3. That's going to be 1, 2, 3. Okay, so let's explain the matrix operations here. This is very simple. It's just real straightforward. So for matrix operations, I know most of you know this, but I'm just going to go over it regardless. Okay, that's a 1 by 3 matrix, and this is a 3 by 3 matrix. So we're going to multiply these two first, these two matrices first, and this is basically a 3 by 1. Yeah, a 3 by 1 matrix. So we can multiply these two here because these two are equal, right? So the column of the first matrix, the number of columns should be equal to the number of rows of the, remember this is R times C, which is row times column. So we can multiply these two. And the way we're going to do it is very simple. We're just going to so tail times tail, middle times middle, arrow times arrow. That's how it's going to be. And then the resulting matrix is going to be this value here with this value here. So we're going to have a 1 by 3 matrix, and then later on we're going to multiply that with this here. So that's going to be basically compatible, 3 by 3, right? Okay. So now we know that we should get a 1 by 3 matrix up here. So I'm gonna speed up here real quick. So that's gonna be equal to, so we put the k out here, and then 0, 0, 1, and then that's gonna be 1, 2, 3. And then this is going to be JO out here, and that's going to be 1, 4, 9, and that's going to be 1, 2, 3. You reduce it even more. Now all you have is this two matrices, so multiply this matrix by this matrix. And final result, finally, this is what we get. K over JO, 3 over 36, and if we reduce that even more, we'll basically get 36 KJO. That's equal to 2.2887 K over JO. So that's your answer right there. That's your fundamental frequency. That's your first frequency, and there you have it. Thank you for watching, and I'll see you in the next one. Bye.